All right, students, do a couple of these different pieces. Homework here in 2.2. So I'll focus on 2.2a. Again, yours is B, but that's not too big of a difference. And again, if you have issues or questions, you can always reach out with specifics. So let's see here. Not exactly sure which ones to do, but again, which of them can be placed into a one-to-one correspondence? One-to-one correspondence means has to have the same number of elements. So you would want to check these and see how many elements are in here. So let's see here. The first one says 1, 2, 3, 4, 5. So that has 5. MNOPQ, that's 5. So I would say yes, this can be placed into a one-to-one correspondence because it has the same number of elements. Question 4 is how many one-to-one correspondences? And again, that's the idea of how can I choose? So for 6 elements, then the first has 6 options, the next has 5, then 4, then 3, then 2, then 1. Let's see here. What is that? 6 times 5, 24, 120. So 720, I think. Grab your calculators for that one. Sometimes they'll get a little bit more restrictive. They'll say how many one-to-one correspondences if X must correspond to 5. Again, it's easy to kind of get hung up on this and be like, well, wait, what does that mean? Well, just make the one-to-one correspondence. Just do it. So if X must correspond to 5, okay, that means X has exactly one option. Okay. Now after that, it doesn't tell us anything else. So Y, so now X and 5 are done. Y could be paired with any of these 4. So Y has 4 options. Z doesn't matter which one it pairs up with. There's only 3 left for Z, and for U there's only 2, and for V there's only 1. So what I get is 1 times 4 times 3 times 2 times 1. So 1 times 2, 2 times 3 is 6, times 4 is, there's 24 options there. Okay, so the more specific you are, picture this, right? The more specific you are, the less options you have, right? This is same as true with you go out to dinner with like a super picky friend, right? Hey, you do not have as many options, right? If not, you've got a lot of options what you could order. Otherwise, very picky people have they're like, no, I need this with the salad on the side. Very, very picky. Okay, let's see here. A couple of these say equal sets. I'm not going to do any of those because I think I've covered that. Find the cardinal number. These are questions basically from section 1.2. These are sequences. Find the sequence. How many numbers are in the sequence? Okay. What else do you have over here? How many subsets does it have? How many proper subsets? So we saw subsets would be 2 to the n. So this would be 2 to the 5. So 32. How many proper subsets? Well, in order to be proper, you have to be less than or you have to be strictly less than in terms of the cardinal number. So there's only one that would be improper, and that would be the set itself. So if the first answer was 32, the next answer is going to be 31. Okay, and it says how many subsets does it have that include the elements A and E? Well, if it has to include A and E in it, then we can start looking at, well, I have to exclude the other ones then, right? So it has to include an A and an E. So obviously the ones with all of those in it will count. And then you can actually go through and say, well, it has to have an A and an E. So there's none with the singles. The empty set won't count. The singles won't count. The doubles will count, but only one of them with an A and an E. And then you can go to the triples, the quads, and the set itself. So it's not too bad. And again, if you're doing triples, this is where you can kind of start using some of your problem solving skills. If I wanted to make a triple and it had to have an A and an E in it, well, just picture it has to have an A and it has to have an E. Now I could make all the other ones, but A and E are gone. I need one more element. How many options do I have? Well, it's a B, a C, or a D. Got it. So I have 3 options there. So there would be 3 sets that look like this. If I thought of sets with 2 elements, there would only be 1 set that looks like this. So 1 of these, 3 of these. Now you can go up. If you go back to the set itself, there's obviously only 1 of those. And I'll leave 1 piece for you to try, which is the sets that have 4 elements in there. Let's see here. Which one? Subset or not? Element or not, sorry, subset or not. So they kind of make you do the question twice, once with element, once with subset. They do have some good if-then statements here. If A is equal to B, does that mean A has to be a subset of B? Excellent question. If A is a subset of B, does that mean it's a proper subset? If it's a proper subset, does that mean it's just a regular subset? So again, think back to the definitions for these. All right. That's really the biggest pieces that I have. I think if you watch the other video, I've gone through how to set these up with the definition of less than. And is there anything else on 2.1? Now then it gets into 2.2. So it's very, very similar. And I think I guess that's about it. Very similar questions throughout. So try that. Again, if you get stuck, try some of the A ones because you know the answers are in the back of the book. I'll make a separate video about the MCs and we'll call it good from there. All right, off you go.